Welcome back to another exciting video on our channel. Today, we have an amazing topic to discuss, DJANGO multi-table inheritance, and we're going to explore it in the coolest way possible. To understand multi-table inheritance, let's imagine we have a project where we're building a website for a company. We have different types of users, such as employee, regular employee, and contract employee. Each user type shares some common fields like name and email, but they also have specific fields unique to their role. In DJANGO, we can represent this using multi-table inheritance. We'll start by creating a base class, let's say employee, which will contain the common fields shared by all user types. Then, we'll create separate models for each user type. These models will inherit from the employee base class. Now, here comes the coolest part. DJANGO automatically creates separate tables in the database for each model involved in multi-table inheritance. It establishes relationships between these tables, allowing us to query and retrieve data efficiently. This means that when we create a name instance, for example, it will be stored in the employee table and the regular employee table, with a foreign key relationship between them. Let's use another example to explain multi-table inheritance in DJANGO. In this example, we have two models, place and restaurant. The restaurant model inherits from the place model using multi-table inheritance. The place model represents a generic location and contains two fields, name and address. It serves as the base model for the restaurant model. The restaurant model inherits from place and adds two additional fields, serves hot dogs and serves pizza. These fields indicate whether the restaurant serves hot dogs and pizza, respectively. Here's an example of how you can use these models. In the DJANGO shell, you will have to import your two models. Let's create a place instance. Next, create a restaurant instance. The restaurant model inherits the name and address fields from the place model, and you can access all the fields of the restaurant model, along with the inherited fields. This demonstrates how multi-table inheritance allows you to reuse fields and behavior from a base model place in a child model restaurant, while still maintaining separate database tables for each model. Because multi-table inheritance uses an implicit one-to-one field to link the child and the parent, it's possible to move from the parent down to the child, as in the above example. However, this uses up the name that is the default related name value for foreign key, and many-to-many field relations. If you are putting those types of relations on a subclass of the parent model, you must specify the related name attribute on each such field. If you forget, DJANGO will raise a validation error. For example, using the above restaurant class again, let's create another field with a foreign key. If you try to run the migration, this will result in the error. Adding related name to the location field would resolve the error. Now, you can make your migrations without the error. When using multi-table inheritance, a new database table is created for each subclass of a model. This is usually the desired behavior, since the subclass needs a place to store any additional data fields that are not present on the base class. Sometimes, however, you only want to change the Python behavior of a model, perhaps to change the default manager, or add a new method. This is what proxy model inheritance is for. Creating a proxy for the original model. You can create, delete, and update instances of the proxy model, and all the data will be saved as if you were using the original model. The difference is that you can change things like the default model ordering or the default manager in the proxy, without having to alter the original. Proxy models are declared like normal models. You tell DJANGO that it's a proxy model by setting the proxy attribute of the meta class to true. For example, suppose you want to add a different ordering on the restaurant model. Currently, the restaurant model is unordered. When you create a restaurant proxy instance, it will have the same data as the corresponding restaurant instance, as they share the same underlying database table. The proxy model does not introduce any new fields or data columns. However, the restaurant proxy class includes a meta inner class with two attributes. Ordering. This specifies the default ordering of restaurant proxy instances when querying the database. In this case, the instances will be ordered by their name field in descending order. Proxy equals true. This attribute indicates that the restaurant proxy class is a proxy model. It distinguishes it from a regular model and allows you to use it as an alternative representation of the original restaurant model. Now, let's migrate our database and open the DJANGO shell to see what just happened to our data when we added a proxy model. Assuming you have already imported the models and set up the database. Retrieve the restaurants using the restaurant proxy model from the database. Create a pretty table instance. Populate the table with data from the restaurants. And finally print the table. Make sure you have the Pretty Table package installed before running this code. The Pretty Table library helps in creating a formatted table with headers and rows, making it easier to visualize the data from the restaurant model in a tabular format within the Django shell. Now, let's retrieve the restaurants from the database. This time we will be using the restaurant model. Create a pretty table instance again. Populate the table with data from the restaurants. Lastly, print the table. In this example, the data from the restaurant model and the restaurant proxy model are displayed in separate pretty table instances. The ordering of the data in the restaurant proxy table will follow the specified ordering name attribute in descending order, while the ordering of the data in the restaurant table will be based on the default behavior, typically by primary key. To summarize, creating a restaurant proxy instance does not introduce any changes to the data itself. It provides an alternative way to access and manipulate the data of the associated restaurant model. The restaurant proxy instances share the same data as the restaurant instances.